Sodium and calcium. Extraction of sodium. Among the alkali metals, sodium and potassium are equally abundant in nature. Sodium occurs as its silicate mineral albite, given by this formula here, and the common name soda feldspar. Other minerals of sodium are Chile saltpeter, or sodium nitrate, and rock salt, sodium chloride. Sodium is a strong reducing agent due to its tendency to lose the valence electron. As a result, sodium cannot be isolated from its oxides or other compounds, with the exception of sodium chloride. Metallic sodium is extracted by the electrolysis of molten sodium chloride in a down cell. The melting point of sodium chloride is rather high at 1073 Kelvin and requires a large amount of energy to keep the sodium chloride molten. Addition of a small amount of calcium chloride will lower the melting point to a convenient 873 Kelvin, reducing energy costs. The diagram below depicts a down cell. A 40 to 60 mixture of sodium chloride and calcium chloride in the molten form is taken inside the iron box lined with fire bricks. The graphite electrode serves as the anode and it rises from the bottom of the tank, which you can see here. The cathode is an iron cylinder. The anode is surrounded by an iron hood with a wire gauze screen attachment which separates the electrodes. So you can see that screen attachment wrapping around here, separating the anode from the cathode. The above separation prevents mixing sodium and chlorine produced during electrolysis. When the current passes through the cell, the following reactions take place. Ionization, followed by reduction at the cathode, and oxidation at the anode. Molten sodium metal is formed at the cathode. Since molten sodium is less dense than the molten sodium chloride, it will rise to the surface where it is collected. Chlorine gas is liberated at the anode. The chlorine gas is released through the dome-shaped hood and collected. Sodium metal formed with the down cell is of high degree of purity and low production costs. Chlorine is also obtained as a valuable side product. Naturally occurring sodium chloride can be directly used in this cell. Sodium carbonate. Sodium carbonate, or soda ash, Na2CO3, is prepared by the Solvay or ammonia soda process. This process consists of a series of reactions. Carbon dioxide is passed through a brine solution saturated with ammonia, forming ammonium bicarbonate according to the reactions below. In 2 steps, we start with carbon dioxide, water, and ammonia to produce ammonium carbonate, and then that ammonium carbonate in the presence of water and carbon dioxide produces the ammonium bicarbonate. The ammonium bicarbonate is then reacted with sodium chloride to form sodium bicarbonate as a precipitate due to its lower solubility. The raw materials used in the process are common salt, NaCl, and limestone. Calcium chloride is a byproduct in the process. This flow chart below depicts the complete Solvay's process, the series of steps for the manufacture of washing soda, or sodium carbonate. Step 1. The brine is saturated with ammonia. A 30% brine solution is saturated in an ammonia absorber with ammonia and carbon dioxide. Any magnesium or calcium salts present as impurities in the brine are precipitated out as carbonates or hydroxides according to the reactions below. So we can see the ammonia reaction with water and carbon dioxide to produce this ammonium carbonate. If there are magnesium or calcium salts present as impurities, they'll react with this ammonium carbonate to form magnesium or calcium carbonate and ammonium chloride. Step 2. The ammonia saturated liquid is then pumped through a filter to remove the precipitated carbonates and then allowed to enter a tall carbonation tower. The tower is fitted with perforated plates. The saturated brine is allowed to enter from above the middle portion of the tower, while carbon dioxide is entering from the bottom of the tower. The downward and upward streams result in the formation of small crystals of sodium bicarbonate according to the reactions below. So we have the ammonia, water, and carbon dioxide forming this ammonium bicarbonate that can then react with sodium chloride to produce crystals of sodium bicarbonate and ammonium chloride. The solution containing sodium bicarbonate is then filtered. The solid deposits on the surface of the vacuum filter while the filtrate is pumped into an ammonia recovery tower. 4. The sodium bicarbonate recovered is heated strongly in a furnace to convert to sodium carbonate according to the reaction below. So we take our sodium bicarbonate, heat it strongly in a furnace to get sodium carbonate, water, and carbon dioxide. The carbon dioxide produced above is recycled into the carbonation tower. 5. The filtrate from step 3 is allowed to flow down the ammonia recovery tower where slaked lime and steam are also introduced. The mixture of ammonia and carbon dioxide is used again for saturating the brine, and a byproduct is this calcium chloride. Calcium. Calcium is one of the most abundant elements in the Earth's crust. Calcium occurs as carbonate in marble, chalk, and limestone. Important minerals of calcium are dolomite, anhydrite, gypsum, fluorspar, and hydroxyapatite. Calcium is a strong reducing agent. Calcium metal is obtained by the electrolysis of the fused anhydrous salt. Fused calcium chloride is mixed with 16% calcium fluoride in a water-cooled graphite crucible, which serves as the anode. Calcium fluoride lowers the melting point and increases the conductivity of the mixture. A movable iron rod acts as the cathode and is raised during the electrolysis so that only the tip of the rod with deposited calcium will be in contact with the fused electrolytes. This enables the metal to be in solid form, preventing it from melting and also easy recovery. As the electrolysis takes place, a continuous rod of calcium starts building up at the cathode. The reactions below show the overall reaction and the half reactions that take place at the electrodes. Here's the overall separation of this calcium chloride into its ions and the reaction of the formation of the solid calcium at the cathode and chlorine at the anode.